In this video, we will be discussing some of the best practices for setting up the drains on one of our overflow systems, as well as showing some of its unique features. Although we used our own system for this video, the basic concept should apply to most implementations using the popular 3-drain configuration, commonly referred to as the bean animal. To start with, we feel it is important to establish the criteria on which we would design any drain system. 1. We want our system to be failsafe, or at least as much as possible. This means making the system robust and removing as many single points of failure as possible. 2. We want our systems to be quiet. We typically keep our tanks in our home's living spaces. For that reason, we want to see our tanks, not hear them. 3. We want our systems to have easy maintenance. If you cannot disassemble your drain easily, you may have a very hard time trying to fix, clean, or modify it later. 4. We want our systems to have a clean installation. Ideally, plumbing should be arranged with the shortest runs possible, keeping it out of the way so that other routine maintenance can be done without the plumbing getting in the way. For this video, we have installed one of our 24-inch overflows on a 40-gallon breeder, along with one of our standard configuration 20-long sump kits. We made the overflow out of clear acrylic so that it is easier to see how it works. The return pump we are using is a C-Chase Synchro 3. We calculate the head loss to put the system at a little over 10-time turnover. Starting with the back of the tank, you have 3 drains. The first one is the one that does 99% of the work. It is the siphon line. This line is completely submerged in water, and all the air is purged from the line. By carefully adjusting the amount of water that can flow through it via a gate valve, it closely matches the output of the pump. Because this line is void of air, it is completely silent and doesn't create any splashing that can lead to salt creep inside your sump. The little bit of water that doesn't flow through the siphon line goes to the open channel. It is important that only a tiny bit of water goes down this line. Because the pipe is filled with air, if a fair amount of water flows through it, it will churn with the air in the pipe and begin to make both noise and bubbles in the sump. The open channel also sets the height of the water level inside the overflow. By raising or lowering the standpipe, the water level will rise or fall inside the chamber. The final chamber is the one that you hope you never have to use, the emergency drain. This is your last line of defense before you must start cleaning salt water off your floor. For that reason, you should leave the top of the pipe open and the outlet above the water in the sump. This way, if the drain is being used, it will make a lot of noise, alerting you so any issues can immediately be fixed. Hard plumbing is usually made up of PVC and comes in 2 different grades or thicknesses, Schedule 40 and Schedule 80. They both have the same outer dimensions and the fittings are interchangeable. However, the Schedule 80 is designed to handle much higher operating pressure and has a thicker wall. Because of this, their inner dimension is smaller and they will flow marginally less water. Schedule 80 has been used in the past because Schedule 40 is an unsightly white with lettering printed on it, while the Schedule 80 was gray and looked nicer. In the last several years, though, Schedule 40 PVC has become available in an array of colors to coordinate with the rest of your system. There are several videos online detailing how to glue PVC, and we suggest checking them out if you have any questions. When it comes to threaded connections, people have been using Teflon tape for years. However, it is not the proper technique. Teflon tape is designed to work with metal pipes where the Teflon helps to guide the threads. Because PVC is plastic already, that extra lubrication is not needed, and the added thickness of the tape adds more stress to the threads, increasing the chance of it cracking. According to Lasco, a major plumbing manufacturer, the right sealant for PVC is non-hardening and compatible with plastic. A link to the article is in the description below so that you can read through it yourself. There is a lot of useful information on their site relating to using threaded connections, ensuring long-lasting leak-proof connections. Starting with the emergency drain, use a single piece of pipe inserted into the bulkhead. The top of the pipe should be about 1 to 1.5 inches below the top of the box. If you aren't flowing near the limit of the system, it can be a little higher, but that distance should be adequate for most systems. After it is all set up, we always like to simulate a full clog of both drains to make sure the emergency can handle the entire flow. The open channel is typically set up using a T, a 90, and an end cap with a hole drilled in it. This setup is typically known as a Durso standpipe. This is such a popular choice for all types of setups because it is cheap to purchase, easy to create, and is quiet compared to just using an open pipe. If the hole is removed, a siphon would be created with the pipe repeatedly surging and then gurgling when water level dropped and the siphon broke. As we said earlier, this drain is the one that determines the water level inside the overflow. Set it too low and you may have issues with the siphon drawing in air, or the weir making noise from the water falling further into the overflow. Set it too high and you may get too close to the top of the overflow or the emergency drain. For the siphon, use a small length of pipe to connect a 90 to the bulkhead, then another small length to connect another 90. The goal here is to get the siphon as close to the bottom of the box without it getting so close that it restricts the flow. That way, you can keep it from creating a vortex and sucking air in from the surface of the water. Before we discuss installing the plumbing, we feel it is important to discuss the size of pipe you should use. The open channel and emergency drains cannot be too large, as they are both open lines. The siphon line, however, is one of those situations where bigger isn't always better. The reason being, for the siphon to function properly, the water flowing through it must have enough velocity to push the air down and out of the line. If you're trying to push 500 gallons per hour through a 1.5 inch line, the water may be flowing so slowly that it will not purge and never start working properly. We typically say that if you're going to be flowing 1,500 gallons or less, the 1-inch drain system is plenty. Over 1,500 up to 3,000 gallons per hour, 1.5 inch lines are best. If you do have a system with 1.5 inch bulkheads and want to flow lower amounts of water, this is fine. Just restrict the siphon line down on both ends of the bulkheads to 1 inch and leave the other two channels at 1.5. A 1-inch siphon is capable of flowing more than 1,500 gallons in most cases, but is one of those situations where you're getting close to the operating limits and you may have to experiment with simulating different levels of line clogging to make sure it is not going to overwhelm the system. We ship our boxes with bulkheads that are threaded on the bottom. That way you can screw in your own adapter without permanently gluing your plumbing to the bulkhead. If your plumbing needs to be changed or the bulkhead becomes damaged, it is a lot easier to change it out. Immediately after the thread to slip adapter, we like to install unions. This way you can easily remove the plumbing when modifying, cleaning, or moving the system. Next up are the plumbing supports. Supports help to hold the weight of the plumbing, taking stress off the bulkheads, and in the case of this style overflow, the glass on the tank. These metal standoffs are our preferred versions for a few reasons. They are easily found at local big box hardware stores like Lowe's. They are also very adaptable and easy to install. The basic clip type is fine for return lines and other lines where you aren't as worried about their exact location. But with an overflow like this, you need it to hold the drain lines in a very specific distance from the stand so that it doesn't put any extra strain on the plumbing. The clamps, threaded rods, and mounts are sold separately but are all cheap. We typically get one 2-foot length of 3/8 inch threaded rod, and it will be enough for the entire build. Position the clamp on your already installed plumbing and screw the mount onto the rod until it is in the proper position to mount the clamp to your stand. Mark the threads with a Sharpie, disassemble it, and cut the rod on the marker line. This will give you a perfect link standoff for your overflow. From there, it is just a simple job of gluing a series of 45-degree fittings to get you to your desired area of the sump. Although 90s are easier to install, they are discouraged because they add a lot of restriction to the water flow. When dry fitting plumbing, just remember that the pipes will stick much further into the fitting when they are primed and glued. Be sure that you do not underestimate the amount of space you will need. Two 45s require a lot more space than one 90, so it is easy to run out of space or miss your mark if you do not anticipate it in your planning. One caveat to using 90s is when running 1.5 inch or higher diameter pipe. When that is the case, you can use sweeping 90s from the drain pipe section of the hardware store. Again, they use more space than a standard 90, so plan accordingly. We typically install the emergency on the opposite side of the sump to the drain line section. The reason being that all 3 lines running into that section make it very crowded. The siphon line requires a valve to restrict the flow. While ball valves are good for turning flow completely on and off, a gate valve gives you much more ability to tune the flow. Only a few degrees of a turn can adjust the water flowing through the system. You want to make sure that the gate valve is installed as close to the end of the line as is practical. One important but often overlooked detail is that you only want the siphon line to be between 1 and 2 inches under the water. If it is 6 or 8 inches underwater, it can have a very hard time purging all the air when it starts up, especially when using low flow or larger diameter plumbing. You can see that by picking which lines we used for each purpose and splitting them up to opposite ends of the sump, we can keep them towards the back of the stand, keeping the middle section completely unobstructed for skimmers, reactors, fuse lights, and other equipment that you may want in the sump. Although not part of the drain system, the return pump line is very important, and a few minor things can make a major difference in how your system works. If your pump doesn't have feet, silicone pot holders have become a popular alternative. We also suggest using a short length of soft silicone tubing before connecting your pump to hard plumbing. Silicone tubing does not bend well because it kinks very easily, so you just want to run a short vertical length. When it comes to clamps for tubing, we prefer the titanium ones from Titan Marine. They are several times more expensive than the standard stainless or the plastic clicking type, but they will literally last forever unless physically damaged. The same basic principles apply when running a return line. Use 45s or sweeping 90s, and use the appropriate number of standoffs to support the plumbing. There are multiple types of outlets, but we have always had good luck with line lock fittings. They are nice because you can easily adjust the outlet to be just below the water level. This way, when the pump shuts off, the return line will back siphon a minimal amount of water. If the water flowing out of your outlet is too strong to partially raise it out of the water line, you can drill a small hole in the bottom side of the outlet just below the water level. It will remain silent when the pump is in use, but when it shuts off, it will draw in air and break the siphon. For it to work properly though, you need to keep the hole clean as part of your regular maintenance. We would not use it as a necessity to keep your system from flooding in case of a power outage, but it is another simple trick that can give you a little extra margin of safety. Obviously, there are a million different combinations possible when setting up a drain system that works well. These are some of the practices we have found that give consistently good results. As always, if you have any questions, don't hesitate to shoot us an email.